Hello students. So in the last session we have discussed completely about acids, bases and salts. Now in this session we have to discuss another important topic which is very useful for 10th class board examinations of different streams like AP, Telangana as well as CBSE boards, that is carbon and its compounds. So coming to the weightage of this chapter in the 10th class board examinations, it varies from 4 to 8 marks in CBSE or in the state examinations. It is not only useful for the 10th class board examinations, and it is also very much helpful in the level 2 examinations of different Olympiads. So let us move on to the discussion about carbon with the introduction of the carbon. So coming to the introduction of the carbon, so as we all of us know here, the symbol of the carbon is C. It is represented always with the capital letter C as per the symbols concept, and its atomic number is 6 and the mass number is 12. Coming to the electronic configuration of the carbon, we know already, so that is 2, 4 as per the shell configuration, like 2 electrons in the K shell and 4 electrons in the L shell. And as per the subshell configuration, if you want to write electronic configuration of the carbon, here it is like 1s2, 2s2 and 2p2. So since atomic number is 6 here, all the 6 electrons are distributed into various subshells in this way. And coming to the position of this carbon in the modern periodic table. So as it is having second shell as the outermost orbit and total 4 electrons in the valence shell. So based on the valence shell electronic configuration, we can determine the position of the element in the modern periodic table. So as for that, here since carbon is having second shell as the outermost shell, so it belongs to the second period, and it is, as it is having 4 valence electrons, it belongs to 4th group in the modern periodic table. That means the position of carbon in the modern periodic table is second period and 4th A group. So these all we had to know at the beginning of the chapter as introduction to the carbon. Coming to the occurrence of the carbon, if you see. So as we all of us know here, carbon can exist or occur in the nature in 2 different forms. The one is in the free state and the second one is in the combined state. So here free state, what does it indicates? The name itself indicating free state in the sense it is not involved in the chemical bond formation, or always it is existing only in the form of elemental carbon. So when it is present only in the elemental form, that form of carbon is called as free state of the carbon, or else if it is involved in the chemical bond formation to form different type of compounds, that state is called as combined state of the carbon. So based on these 2 states, here in the nature carbon can be available in these 2 different forms we are dealing. So the best examples if you take for the free state of the carbon, the different allotropic forms of the carbon we can consider, that is like a diamond, graphite, fullerenes, and amorphous allotropes if you consider, those are coal, coke, etc. So all these are considered as free state of the carbon. Coming to the combined state of the carbon, so general examples or basic examples if you consider, we can say it is methane or ethane. So not only these 2 examples, any hydrocarbon or hydrocarbon derivative in general we can consider as a combined state of the carbon. And moreover, you can see here calcium carbonate or carbon dioxide and carbon monoxide. So even these 3 compounds also we can consider as the combined state of the carbon. And coming to the type of bonding observed in the carbon, so mainly here what type of chemical bond formation we can see in the carbon we have to know before going to study about carbon and its compounds. So here as I told before, the electronic configuration of carbon already we know. So what is the electronic configuration of carbon? That is 1s2, 2s2 and 2p2. That means carbon is having totally 4 valence electrons. So these are the 4 valence electrons we can observe. 2 electrons are present in S subshell and 2 electrons are present in P subshell. So the representation of these electrons if you consider here like 1s2, 2s2 and 2p2. So as per the ground state of electronic configuration of carbon, how many valence electrons or how many unpaired electrons we are having or we can observe, that is 2 unpaired electrons are present in the carbon. But here the second representation, if you observe, that is excited state of electronic configuration of the carbon. So now here, whenever carbon is absorbing some amount of energy either from naturally or during the chemical bond formation, by the absorption of energy we can observe the excitation or the promotion of one s electron into the p subshell. So that results in the representation of the second type of electronic configuration, that is what we are calling as excited state of electronic configuration. So coming to the excited state of carbon, the electronic configuration can be written like 1s2, 2s1 and 2p3, and it can be represented like this. Totally, as per the excited state of configuration, how many unpaired electrons we can observe in the carbon? So yes, you are right, that is totally 4 unpaired electrons are present in the valence shell of the carbon. So as per this, how many chemical bonds carbon atom can form is, simply we can say that 4 different chemical bonds formation we can observe by the carbon in the elemental form. So now here, so based on this ground state electronic configuration and excited state of electronic configuration, we can confirm that carbon can form 4 different bonds with the different elements. So now, what type of bonding can be observed in the carbon? Either it is covalent bond formation or ionic bond formation. So here, in order to know, I have listed out a few important points on the board. So the first one is here, carbon cannot form C+4 ions or C-4 ions. We have to know the reason why it is. Carbon cannot form C+4 ion or C-4 ions. And secondly, the promotion of electrons. The promotion of electron. So how it is possible? Already I said it is always possible by the absorption of energy. So whenever carbon is absorbing energy, we can observe the excitation of levels are to the next subshells in the same energy level. So like that, here first I would like to discuss why carbon cannot form C+4 or C-4. In the previous sessions, we know about the periodic table and the important periodic trends. So in the periodic trends, most importantly if you consider, we know what is meant by ionization potential and what is meant by electronegativity. So coming to the important properties like ionization potential and electronegativity, particularly to the carbon. So these properties of carbon are somewhat moderate. So the ionization energy of the carbon is not too high or too low. In the same way, the electronegativity of the carbon is also not very high or not very low. So as per these two properties, we can say, imagine if the element is having more ionization energy, what type of property it can exhibit? Either it is electropositive or electronegative. So whenever the element is having high ionization energy, we can say that the element will show more electronegative character. If the ionization energy is less, we can expect more electropositive character for the respective element. So here, these two properties like ionization energy as well as electronegativity of carbon are somewhat moderate, not too low or not too high we are telling. So coming to the carbon, so when it is involved in the bond formation, so the loss of electron or gain of electron is possible or not. So as I said here, the electronegativity and ionization energy of the carbon are moderate. That means carbon cannot show the highest electropositive character or highest electronegative character. That means the complete loss of electron or the complete gain of electron is not possible for the carbon. So as a result of that, we can conclude carbon cannot form either C+4 by losing 4 electrons or either C-4 by gaining 4 electrons in order to get the octet configuration. So here, since carbon cannot form either C+4 or C-4, here I am asking you one question. Whenever the ion formation is not possible for any element, can we observe the formation of ionic bonds? No, it is not possible. So whenever either loss of electron or gain of electron is possible for the element, only in such cases we can observe the formation of ionic bond. But here carbon cannot form either C plus 4 or minus 4. So, we can conclude that carbon cannot form ionic bonds. So, what type of bonding is observed in the carbon, we have to know. So, let us move on to the nature of bonding or type of bonding formed by the carbon. So, here finally, we can conclude carbon forms covalent bonds. Why? Because it cannot form either C plus 4 or C minus 4. Loss of electron or gain of electron is not possible for the carbon. So, always it will be going for sharing of the electrons with the different elements. We know what type of bonding is observed whenever the electrons are involved in the sharing process, that is nothing but covalent bond. So, carbon can form covalent bonds by the sharing of electrons. So, here we have to interlink these two factors, the promotion of electron, that is from ground state electronic configuration to excited state configuration, how electronic configuration will be changes, and what type of bonding is observed here. These two are very important factors in order to explain the type of bonding observed in the carbon. So, here as I said here, normal ground state electronic configuration of carbon, it has only 2 unpaired electrons, but when it comes to excited state of electronic configuration, how many unpaired electrons we can observe in the carbon? Yes, you are right, that is 1, 2, 3 and 4. So, total 4 unpaired electrons are present in the excited state of carbon. So, these 4 unpaired electrons are involved in the sharing process with the different elements like fluorine, chlorine or bromine, hydrogen, so like that, and results in the formation of 4 different bonds like covalent bonds. So, now here I would like to ask you one more question. Here if you observe, I said the promotion of electron is possible by absorption of energy. So, in general, from where carbon can get this energy? From the nature itself? No. So, here generally carbon can absorb some amount of energy. So, normal ground state configuration is like this with the 2 unpaired electrons. So, whenever it is involved in the chemical bond formations to form a different compound. So, here after formation of 1 or 2 chemical bonds, if you observe, always we know the formation of bond is exothermic process. Why? Because in order to get stability, generally elements are involved in the chemical bond formations. So, as a result of chemical bond formation, generally any atom will lose some amount of energy. That means we can conclude the chemical bond formation is always exothermic in the nature. So, now during the chemical bond formation, we can observe the release of some amount of energy. So, that released energy will be absorbed by carbon atom itself, so that we can observe the promotion of electron from this 2s subshell to the 2p subshell. So, that is required here, so that we can observe the promotion of electron. So, whenever the electron is being promoted to the 2p subshell, carbon can have 4 valence electrons and in unpaired condition, so that carbon can form different bonds with the elements. So, in order to explain this type of bonding in the carbon, that is covalent bonding. So, 2 important concepts we are supposed to recap once, which already we have learned earlier, that is valence bond theory, and the second one is concept of hybridization. So, here first let us move on to valence bond theory. So, the theory valence bond theory is mainly proposed or published by Linus Pauling and John C. Slater. These are the 2 people who involved in the development of valence bond theory in order to explain the way how covalent bond formation is observed by the overlapping of atomic orbitals. So, here the main concept how they have explained the formation of covalent bonding is by the involvement of overlapping of atomic orbitals. So, as we all of us know, whenever the 2 different elements of atoms are involved in the chemical bond formation by covalent bond. So, we know that is possible by sharing of electron pairs, and in turn that is possible by the overlapping of atomic orbitals. So, as per this valence bond theory, they have clearly explained the way how overlapping is possible between the atoms during chemical bond formation, and moreover the strength of chemical bond also can be explained by using the extent of overlapping process. So, here I am taking the example of methane, that is nothing but CH4, a very basic hydrocarbon, that is first member in the hydrocarbon series we can say, that is CH4. So, I will try to explain the way how covalent bond formation is possible as per valence bond theory in methane molecule. So, here as I said, this is CH4, and in the before concept we have learnt about the electronic configuration of carbon. So, either in the ground state configuration or in the excited state of configuration. So, if the carbon is present in ground state of electronic configuration, it has 2 unpaired electrons already we know, but whenever it is entered into the excited electronic configuration, it will have 4 unpaired electrons. So, let us imagine the carbon is having 2 unpaired electrons at the beginning, that is in the ground state electronic configuration. So, here the picture the diagram represents here carbon with 4 hydrogen atoms, and we know carbon electronic configuration is 1s2, 2s2 and 2p2. Coming to the hydrogen, the atomic number of hydrogen is 1 and it has the configuration of 1s1, that means 1 electron is present in the S subshell. So, here before going to explain this methane molecule, first as per this VBT how overlapping process can take place we have to observe. So, here I am taking the 2s subshell of the carbon and 1s subshell of the hydrogen. So, here both subshells are having unpaired electrons. Here this is 1 electron present in the 2s subshell of carbon and this is other electron present in the 1s subshell of the hydrogen. So, when these two are involved in the overlapping process, so overlapping in the sense we can say that simply partial merging of these two atomic orbitals. So, here when these two orbitals are involved in the partial merging process, we can see the overlapping of atomic orbitals. So, as a result of this overlapping, the 2 unpaired electrons of 2s subshell of carbon and 1s subshell of hydrogen will be involved in the sharing process that results in the formation of a chemical bonds, that is nothing but covalent bond. So, here as per this valence bond theory, there are 2 very important conditions are required in order to form covalent bonds by the overlapping process. So, if you see here, these are the conditions essential for the overlapping of atomic orbitals. The first important condition is the atomic orbitals should be having unpaired electrons. The overlapping atomic orbitals should be having unpaired electrons, then only overlapping process can be done in an effective manner. And the second essential condition is the unpaired electrons of different atomic orbitals which are involved in the overlapping process should have opposite spins. So, here the diagram itself indicating 2s subshell of carbon is having a clockwise direction and this is having anti-clockwise direction, clockwise direction. So, the spin of electron is different here. The 2s electron of carbon is having one type of spin and 1s electron of hydrogen is having other type of spin. So, whenever the atomic orbitals are involved in the overlapping, by obeying these 2 conditions, we can observe the formation of covalent bonding. So, let us move on to the methane molecule now. So, as we have discussed it so far, so here carbon is having 1s2, 2s2, 2p2 configuration, that is 2 unpaired electrons are present. And in the earlier case, I have already explained the way how chemical bond formation is observed by the promotion of electron by absorbing some amount of energy. So, imagine at the beginning carbon is having only 2 unpaired electrons, the excited state of electronic configuration, that is nothing but 1s2, 2s1 and 2p3. So, total 4 unpaired electrons now carbon will be having, that continues to the formation of remaining 3 chemical bonds in the combination like 2p and 1s of hydrogen, 2p of carbon and 1s of hydrogen, 2p of carbon and 1s of hydrogen. So, like this overall in the methane molecule, if we consider, overlapping of atomic orbitals is possible or observed, and what type of overlappings we can see is 1s and 2s combination is involved, and 3 1s and 2p combinations or overlappings are involved. So, in this way, as per the valence bond theory, we can easily explain the way how covalent bond formations are taking place by overlapping of atomic orbitals. And the next concept is hybridization process. This concept also proposed or developed by Linus Pauling only. So, here why we have to study this hybridization concept. So, as per valence bond theory, already we know how chemical bond formations are possible very clearly, but why we have to study hybridization process? In order to overcome the drawbacks of valence bond theory, we have to know about hybridization concept. So, what are important drawbacks of valence bond theory if you observe? So, the bond strength can be mainly explained by valence bond theory. Why? Because the extent of overlapping will decide the bond strength, already we know that. But here coming to the shape of the molecule or bond angles of the molecule cannot be determined by using valence bond theory. That is a most important drawback in the valence bond theory we know. Here, but in the case of hybridization process, in order to overcome the drawbacks of valence bond theory, very clearly we can explain the shapes of the molecule as well as the bond angles of the molecules. So, let us see the hybridization concept. So, simply we can define the hybridization as the redistribution of atomic orbitals. We can define it as the redistribution of atomic orbitals of almost equal energy. So, that is nothing but hybridization we can say. So, here I am using the term redistribution. So, what happens during the hybridization process? So, here the intermixing of pure atomic orbitals will take place that results in the formation of equal number of identical hybrid orbitals. So, that is nothing but hybridization process we can say. So, students, here you should have a clarity or the difference between overlapping and intermixing process. So, as I said, as per the valence bond theory, overlapping in the sense partial merging of the atomic orbitals we know, that is between atoms we can observe, that is overlapping is nothing but or it is a process occurs between atoms. So, simply I can say that overlapping process is intra-atomic process. So, simply I can say that overlapping process is interatomic process. But coming to the hybridization, we are telling the complete intermixing of pure atomic orbitals of same atom. That means hybridization process is intra-atomic process. So, before going to the bond formation, every atom will undergo hybridization process in order to redistribute the energies of pure atomic orbitals. So, as per this concept, most importantly we have to study or know about three important types of hybridizations. One is sp3 hybridization, second one sp2 hybridization, and the third one is sp hybridization. So, these are the three important types of hybridizations which are mainly helpful in order to study the compounds formed by carbon. So, let us see one after one. As we said, it is nothing but intermixing of pure atomic orbitals. We know that here intermixing of one s orbital and 3 p orbitals we can observe. That results in the formation of equal number of identical orbitals. That those are nothing but hybrid orbitals. So, here intermixing of 1s and 3 p atomic orbitals of carbon are involved in the sp3 hybridization process that results in the formation of 4 sp3 hybrid orbitals. So, these obtained 4 sp3 hybrid orbitals are arranged in the tetrahedral arrangement. So, the shape of the molecule, whenever the carbon is undergoing sp3 hybridization, we can observe the shape of the molecule is tetrahedral in nature. And coming to the bond angle. So, here what is bond angle? Bond angle can be simply defined as the angle between two different bonds or two adjacent bonds in the molecule. Simply we can define bond angle as the angle between two adjacent bonds in the molecule, we can say that. So, here as per this tetrahedral arrangement, here it is represented. If I take the angle between any two bonds, it will be equal to 109 degrees and 28 minutes. So, that is the bond angle observed in the sp3 hybridization process. So, here based on these factors, if you want to illustrate an example, I would like to take up methane as the best example for sp3 hybridization. So, already we have discussed as per valence bond theory the way how methane molecule can be formed. So, there simply overlapping of pure atomic orbitals is observed in order to form the methane molecule. But here first of all carbon will undergo hybridization process, that is sp3 hybridization, then it will go for the overlapping process as per the VBT. So, now carbon undergoes sp3 hybridization in methane molecule, that results in the arrangement of a tetrahedral structure of all the 4 sp3 hybrid orbitals. Okay. So, here that is tetrahedral arrangement, and after hybridization process the resultant hybrid orbitals will be involved in the overlapping process as I said with 1s orbitals of the hydrogen atom. So, here first bond if I take, this is sp3 hybrid orbital and this is 1s orbital of hydrogen. So, here the combination simply we can say this bond can be formed by sp3 hybrid orbital and 1s pure orbital of hydrogen. So, like that 4 different bonds we can observe. So, this is hybridization, sp3 hybridization observed in the methane molecule. So, in the same way we know that sp2 hybridization also we can. So, here intermixing of 1s and 2p orbitals results in the formation of 3 sp2 hybrid orbitals. The shape of the molecule whenever it is involved in the sp2 hybridization is trigonal planar and the bond angle is 120 degrees. Best example we can see here, that is ethene molecule C2H4, that is ethene molecule. Here also you can see first of all hybridization of both the carbon atoms, we can see that results in the formation of a trigonal planar hybrid orbitals and overlapping of hydrogen atoms, 1s orbitals of hydrogen atoms is done in order to form the ethene molecule. And in the same way sp hybridization also if you observe, that is intermixing of 1 s orbital and 1 p orbitals, that results in the formation of 2 sp hybrid orbitals, and shape here it is, since only 2 hybrid orbitals are obtained in this process, the shape of the molecule always will be linear and bond angle is 180 degrees. The best example we can say, that is ethyne or acetylene molecule. So, here also first sp hybridized orbitals are formed, then it will go for the overlapping with the 1s pure atomic orbitals of the hydrogen.